Greenland does not give up its secrets easily. For millions of years, one of the most remote and hostile places on Earth has sat in frozen silence, locked beneath a sheet of ice so massive it can be seen from space. Scientists have spent decades studying it from the outside, measuring its surface, tracking its edges, watching its glaciers crawl toward the sea. But it is only in recent years, as drilling technology, satellite radar, and genetic analysis have advanced beyond anything previous generations could have imagined, that researchers have begun to understand what is actually happening inside this frozen giant. And what they are finding is nothing short of extraordinary. Beneath the white silence, Greenland has been quietly holding onto some of the most remarkable and some of the most disturbing discoveries in the history of modern science. The story begins not with ice, but with life. In the far northern corner of Greenland, in a remote geological zone known as the Cap Copenhagen Formation, a team of international researchers achieved something that had never been done before. By carefully extracting sediment cores from the frozen earth and applying cutting-edge environmental DNA sequencing techniques, they recovered genetic material that is approximately 2 million years old. Published in the journal Nature in December 2022, this discovery represents the oldest DNA ever successfully retrieved and sequenced anywhere on the planet, surpassing the previous record by a full 1 million years. What makes this find so astonishing is not merely its age, but what the DNA actually reveals. 2 million years ago, northern Greenland was not the barren Arctic desert it is today. The genetic fragments paint a picture of a thriving, warm ecosystem, one filled with forests of birch, poplar, and spruce trees, with mosses and ferns carpeting the ground beneath them. Insects buzzed through the canopy. Coastal waters were home to horseshoe crabs and a variety of marine organisms. And roaming this green northern landscape were mastodons, the enormous, shaggy ancestors of modern elephants. Animals that had no business being this far north by any map of ancient migration scientists previously held to be accurate. This rewriting of Greenland's biological past is more than a scientific curiosity. Researchers are now studying these ancient genetic sequences to understand the specific biological mechanisms that allowed these plants and animals to survive in conditions that closely mirror what climate models predict Earth is heading toward in the coming centuries. The ancient ecosystem of northern Greenland represents a real-world case study, a 2-million-year-old field test of life adapting to a warmer, ice-free Arctic. As the ice retreats today, it is not creating something new. It is slowly exposing something very, very old. If ancient DNA was the first shock, the second came from deep penetrating radar. When NASA scientists and university researchers began using airborne radar surveys to map the terrain beneath Greenland's ice sheet, a project that became part of NASA's Operation Icebridge, they discovered something that no satellite image could ever have revealed. Hidden beneath nearly 2 miles of solid ice, there is a canyon. Not a small canyon. A mega canyon, stretching over 460 miles from the center of the island toward its northern coast. This buried valley is longer than the Grand Canyon and, in some places, comparable in depth. First described in detail in a study published in Science in 2013 by researchers from the University of Bristol and collaborating institutions, the Greenland Mega Canyon appears to have been carved by ancient rivers long before the ice sheet existed. Rivers that flowed across what was once a temperate landscape, long before the Arctic froze over. But the canyon is not simply a relic of a warmer past. It is an active and critically important structure in the present. Scientists believe this enormous channel functions as a subterranean highway for meltwater. As surface temperatures rise and the ice above melts, water seeps down through cracks and shafts in the glacier, eventually reaching the canyon floor. There, it moves in pressurized torrents beneath the ice, a hidden river flowing in total darkness, miles beneath the surface. This water acts as a lubricant between the base of the ice sheet and the bedrock below. Instead of being anchored firmly to the rock, the ice above the canyon is, in places, essentially floating on a film of pressurized water. This makes it far easier for enormous sections of the glacier to slide laterally toward the ocean. The implications for sea level rise are difficult to overstate. Prior to these discoveries, climate models struggled to explain why Greenland's glaciers were moving so much faster than expected. The mega canyon and the liquid water flowing through it provides a significant part of the answer. Greenland has a built-in drainage and lubrication system that, as temperatures rise, works increasingly against the stability of the ice sheet as a whole. As remarkable as the geology of Greenland is, perhaps the most unsettling discoveries are biological. For decades, scientists largely assumed that the interior of the Greenland ice sheet was, for practical purposes, sterile. The conditions, extreme cold, high pressure, total darkness, near-zero nutrients, seemed incompatible with life. That assumption has been dismantled piece by piece. Researchers studying the surface of the Greenland ice sheet have documented vast blooms of snow algae, organisms that darken the ice surface and have a measurable effect on how much sunlight the ice absorbs. Dark ice absorbs more solar radiation than white ice, which means these biological blooms are actively accelerating melt. But living alongside these algae, scientists have found something even more unusual: giant viruses. These are not viruses in the conventional sense. Unlike the tiny, relatively simple viral particles most people are familiar with, giant viruses, sometimes called gyruses, are biological anomalies. They can reach sizes of up to 2.5 micrometers, larger than many bacteria, and carry genomes of extraordinary complexity. Deeper in the system, in the permafrost surrounding and beneath the ice, the biological stakes rise further. Permafrost, ground that has been continuously frozen for thousands to hundreds of thousands of years, is a time capsule. Scientists working in Siberia have already successfully revived ancient viruses extracted from permafrost samples nearly 50,000 years old, demonstrating that certain pathogens can remain structurally intact and infectious after extraordinarily long periods of freezing. Greenland's permafrost represents a similar and comparably unstudied archive of ancient biological material. As that permafrost thaws, and it is thawing measurably and irreversibly in many areas, it releases organisms that have had no contact with modern ecosystems, modern immune systems, or the modern biological environment in any form. This is not a prediction of a dramatic Hollywood-style outbreak. It is a more subtle, and in many ways more troubling concern: the gradual reintroduction of ancient microbial agents into a world completely unprepared for their unique characteristics. Beyond direct biological risk, these ancient microbes also accelerate the decomposition of long-frozen organic matter, releasing stored carbon, in the form of methane and carbon dioxide, back into the atmosphere. This creates a feedback loop, in which warming thaws permafrost, which releases microbes, which decompose organic matter, which releases greenhouse gases, which causes further warming. In 2018, a team of researchers from the University of Copenhagen published a paper in the journal Science Advances announcing a discovery that stunned the geological community. Buried beneath the Hiawatha Glacier in northwestern Greenland, hidden under nearly a kilometer of ice, they had identified a massive meteorite impact crater. The crater is approximately 31 kilometers, roughly 19 miles, in diameter, making it one of the 25 largest impact craters ever identified on Earth, and the first ever found beneath the continental ice sheet. The discovery was made by analyzing radar data collected during NASA's Operation Icebridge surveys, which showed a distinctive circular depression in the bedrock with a raised central peak, the classic signature of a large impact event. The crater's fresh appearance in radar scans initially led some scientists to speculate it might be geologically recent, possibly coinciding with human prehistory. However, subsequent dating analysis using argon isotopes and uranium lead methods applied to shocked mineral grains from the site established that the impact occurred approximately 58 million years ago, during the Paleocene epoch, a time when Greenland was forested and ice-free. The energy released by the impact would have been enormous, equivalent to hundreds of nuclear detonations, vaporizing bedrock, sending shock waves through the crust, and injecting enough material into the upper atmosphere to temporarily affect global climate. Today, that ancient scar still matters. The Hiawatha Glacier, which flows directly over the crater, is among the most dynamically active glaciers in the region. The disrupted topography of the crater floor creates instability in the ice above it, making the glacier more prone to fracturing and accelerated flow. An event that happened 58 million years ago is influencing the behavior of ice and meltwater in the 21st century. Furthermore, The discovery of the Hiawatha crater prompted scientists to look more carefully at the surrounding bedrock. Using similar radar survey techniques, researchers identified what may be a second, larger impact structure approximately 183 kilometers away. If confirmed through further analysis, Greenland may have experienced multiple major impact events, and the structural weaknesses those collisions left in the bedrock may be contributing, even now, to how the island responds to the loss of ice mass. Not all of Greenland's buried secrets are ancient. Some are modern, and some are deeply inconvenient. During the Cold War, the United States military, under a classified program known as Project Iceworm, explored the possibility of using the Greenland ice sheet as a platform for concealed nuclear missile infrastructure. To test the concept, they constructed Camp Century, an underground facility carved into the ice, capable of housing more than 200 military personnel and powered by a portable nuclear reactor. The project was abandoned by 1967 when engineers recognized that the ice sheet was not the static, permanent structure they had assumed. The tunnels warped and collapsed under the pressure of moving ice. The reactor itself was removed. What was not removed included approximately 200,000 liters of diesel fuel, significant volumes of polychlorinated biphenyls, and thousands of liters of radioactive wastewater and sewage. These materials were buried under the assumption that the ice would entomb them permanently. Research published in Geophysical Research Letters in 2016 by scientists from the University of York calculated that under current warming trajectories, the net ice balance at Camp Century could shift from accumulation to loss before the end of this century, potentially exposing these contaminants to the environment as early as the 2090s. The legal and diplomatic questions surrounding this contamination are unresolved. The waste is located in Greenlandic territory, under Danish jurisdiction, and was deposited by the United States military. No cleanup framework currently exists. If the materials reach the marine environment, they risk entering the food chain of ecosystems on which indigenous Inuit communities have depended for generations. The Cold War infrastructure buried in Greenland's ice was built on an assumption of permanence. Climate change has invalidated that assumption. Every discovery emerging from Greenland carries consequences that extend far beyond the island itself. The Greenland ice sheet contains enough frozen water to raise global sea levels by approximately 7.4 meters, more than 24 feet, if it were to melt entirely. A total melt would unfold over centuries, but the mechanisms now understood to be operating beneath the ice, the meltwater rivers in the mega canyon, the Moulin drainage systems punching through miles of glacial ice, the biological feedback loops in the permafrost, suggest the timeline of significant impact is considerably shorter than older models predicted. The discharge of cold, fresh meltwater into the North Atlantic is already measurably affecting ocean circulation patterns, particularly the Atlantic meridional overturning circulation, the vast system of ocean currents that transports heat northward and keeps European climates relatively mild. Research published in multiple peer-reviewed journals in recent years has raised significant concern about the stability of this system, with some analyses suggesting a meaningful reduction in its strength is possible within this century. A major slowdown would have cascading consequences. Colder winters and altered precipitation across Western Europe, disrupted rainfall patterns across the tropics, and reduced capacity for the Southern Ocean to absorb atmospheric carbon. Greenland is not a remote scientific curiosity. It is one of the fundamental regulators of the planetary systems that modern civilization has been built around. The ancient DNA, the buried canyon, the awakening microbes, the cosmic scars, the Cold War waste, and the accelerating ice loss are not separate stories. They are chapters of the same story, a story about a frozen archive that is opening, and a world that is only beginning to understand what that means. The ice kept its secrets for millions of years. It is no longer keeping them.